In this lesson, we're going to be talking about slope, or rate of change. Let's first go ahead and take a look at what slope means graphically. You can see here that I have 4 examples of lines that have a given slope. And you can see that the first line has a positive slope, and you can see that that little biker is going up the hill. So you always read the graph from left to right, just like you're reading a book. So we see that biker going up the line. That represents a positive slope. So in a couple minutes, we're going to be calculating or computing the actual numerical value of the slope. This would mean that the numerical value would be a positive number. And the second graph here, you can see this represents a negative slope. You can see the biker is going downhill or down the slope. And if you read this graph from left to right, you'd be reading it and it would be going in the negative direction. So this would represent a numerical value if you calculated the slope of this line. The next 2 are kind of interesting. The first one we want to look at is a 0 slope. And if you were to calculate this numerical value of this slope, it would be truly 0. It represents a horizontal line. Unlike the next graph, this is called an undefined slope, where your slope, there is no numerical value for this type of slope. And the way we like to remember it is, if you look at our little biker here, it's undefined what's going to happen to this little biker when he rides down a slope of that's undefined. All right, let's go ahead and talk about the variable that we used for slope. I know it's kind of strange, but we're going to be using the variable m to represent the slope of a line. And we'll be actually incorporating m into a couple formulas in the weeks to come. M is represented by the rise over the run of the line. And what the rise represents is the change in the y coordinates. So remember, y is up and down on your coordinate plane. So it's all the way from the ground to the sky, I like to say. That's the change in the y values. And the run represents the change in the x values. Remember, those are the horizontal values. So the change in those x values represents the run. Let's go ahead and take a look at what this rise over run idea actually means in regards to a slope. So let's go ahead and take a look at some slopes. So these first 2 examples are positive slopes, and you can actually see that by just looking at the line itself. You can see that if you read these lines from left to right, you'd be going upward in that positive direction. So this is how you calculate the slope. Now let me show you. I'm going to go ahead and I'll choose orange for my color here. I'm going to start at any point on the line. I do have 2 given points on this first line, but you don't necessarily have to choose those points. I usually like to choose points that are nice cross-section points. And these 2 examples just happen to be 2 cross-section points. But in future lines that we look at, I'll show you in the next example, you don't necessarily have to choose those dots that I give you. So I like to start with the dot closest to the left side of the graph, although you could start with the other. And I'm going to start right here, and I'm going to rise, and I'm going to run. And my goal is to get from one dot to the other. So you can see that I rose 1 space here. That's my rise. So I'm going to go ahead and put that up here. And then my run, remember, I'm counting the spaces. So it looks like I have 1, 2, 3, 4, 5. This is 6 spaces. So my run would represent 6. So my rise over run simplifies down to 1/6. So the slope of this line is 1/6. Notice how it's a positive number, and it's okay that it's a fraction. It's not always going to be a fraction, but in this case it is. Now I do want to show you what happens when you actually start with the other point and go the other way. If I started at this point here, and I wanted to rise and run to get to the other point, I would have to rise this way. Now I know this is weird, but this is rising -1. See, I'm going in that negative direction, and I'm running -6, right? Rise, run. And if you think about that, I'm going to write it here. My rise over my run in that case would be -1 over -6, which we know simplifies to 1/6. So no matter which direction that you go, whether you move to the left or to the right, you're going to end up with the same slope of 1/6. And the slope of this line will always be 1/6. It's never going to change. Okay, let's go ahead and take a look at some more examples. So in this next example, you see I have 2 points that are given to me. And what I was talking about earlier is that I don't necessarily have to start with those 2 points. Do you see how I have some other points that are at nice cross sections on this line? I could choose any of those points. Actually, there's one up here as well. I could choose any of those points. All I need is 2 points on the line to determine the slope. So let's go ahead and start with, yikes. Let's go ahead and actually do the ones that we were given. Let's start with those. So I'm going to go ahead, let me go ahead and erase these so I don't confuse anyone. I'm going to start with this point here. And I want to get to the top one. So I'm going to rise 2, and I'm going to run 1. So a rise of 2 and a run of 1 simplifies down to 2. So the slope of this line is +2. And you always want to simplify if you can. You never want to leave a number over 1. You always want to simplify. Now, I do want to show you something kind of neat here. Now, let's go ahead and say that I'm going to choose 2 different points here. Let's go ahead and choose this point way down here, okay? And then we'll go ahead, let me erase this. And we'll go ahead and choose this point way up here. And let's find the rise and the run between these 2 points. I'm actually going to change my color so you can see it a little better. Right here and right here. So I'm going to rise 1, 2, 3, 4, 5, 6. And I'm going to run 1, 2, 3. And so if I simplify that, think about this. My rise over my run would be 6 over 3, which would again simplify to 2. See how these are the same? No matter what coordinates that you use on that line, the slope of the line will always be the same, as long as you calculate it properly. So those are 2 examples of 2 positive slopes. Now let's go ahead and look at some negative slopes. And negative slopes actually work the same way. So let's look at these ones. First of all, you know that it's negative because when you read it from left to right, like you're reading a book, it's going downhill. So we're going to treat this exactly the same way. I'm going to go ahead and start with this point here. And I'm going to rise -3. You have to be careful which direction you're going. And I'm going to run +4. So my rise is -3 and my run is +4. And I cannot simplify this. This is fully simplified. So therefore, my slope of this line is -3 over 4. And I would just write it just like that. All right, let's take a look at the next one. This one's kind of neat too. So I'm going to go ahead and start with this point here. And I'm going to rise -3. And I'm going to run +3. So here it is, -3 over 3. Remember to always simplify this down, and that'll simplify down to -1. So the slope of this line is -1. Now, again, you could have chosen 2 other points on this line. Let me show you what I mean. I love a slope of 1 because it's kind of easy to recognize. Like, what if I just wanted to use this point here and the origin? Notice how I have a rise of -1 and a run of 1. So -1 over 1 would still give me -1. So I kind of like a slope of 1 or -1. They're kind of easy to work with. All right, so there are your examples of positive and negative slopes. Let's go ahead now and look at those there's a little bit of different ones. You have the 0 slope and you have the undefined slope. And let me show you why it's actually 0 and undefined. So the 0 slope, let's actually calculate it, okay? Think about this. I'm going to do the same thing that I did and the same procedure I did in the last examples. I'm going to start at this point here and I'm going to try to get to the other point. So ask yourself, how many spaces am I going to rise? And I'm not going to rise any. So I'm actually going to put a 0 on top. In this example, how many spaces am I going to run? Well, 1, 2, 3, 4 spaces. And 0 over 4 simplifies down to 0. So anytime you have a horizontal line, your slope will always be 0. Now let's take a look at this next example and see why it's undefined. So I'm just going to go ahead and start with this point here. And I ask myself, actually I'm going to start at the other one just for the purposes of this example. All right, I'll start here. How many am I going to rise to get to the other point? Well, 1, 2. So there's my rise. How many am I going to run? Well, I don't have to run at all because I'm already there. So my run would represent 0. And try to putting 2 divided by 0 or anything divided by 0 in your calculator or in Desmos. You're going to get something like error, syntax error, because this is impossible. You cannot divide by 0. And therefore, this is an undefined slope. And sometimes we just like to say UND is representing our slope. So remember, the variable that we use for slope is m. So I'm going to put m is equal to 0 over here. And then I'm going to say that m is equal to undefined over here. Okay? All right. So now that we've looked at all 4 slopes and how they work, let's go ahead and actually calculate the slope of a line using the slope formula. This is your first formula of the year. Well, maybe it's not quite the first, but this is the formula for slope. You will need to commit this formula to memory, but once you use it a couple of times, it becomes kind of like second nature here. So let's go ahead and talk about how it works. So here's the formula. M, which is our slope, is equal to y2 minus y1 over x2 minus x1. Now it looks a little confusing, but let me just show you where we're getting all of those variables and all those numbers. The y1s and the y2s and the x1s and the x2s just represent numbers. That's it. So watch what we're going to do. Notice that I'm given 2 coordinates. Remember when we graphed a line to determine the slope, we used 2 coordinates. This is the same exact thing we're doing here. I'm going to call this first coordinate, I'm going to call this x1 and my y1. And I'm going to call this one x2 and y2. And if I wanted to, I could have called that second coordinate x1, y1, and I could have called the first coordinate x2, y2. It does not matter what you name each of those numbers as long as you're consistent. So let's go ahead now and plug it into the formula. So m equals, I want to grab my y2 because that's the first thing in the formula. So negative 5 minus my y1, which is 3, divided by my x2, which is negative 3, minus my x1, which is 1. And now I just want to go ahead and simplify it. Negative 5 minus 3 is negative 8 in my numerator. Negative 3 minus 1 is negative 4 in my denominator. If I simplify that down, I get 2. So the slope of this line that is created by these 2 points is going to be 2. Simple as that. Okay, let's try one that's just a little bit harder. So let's go ahead and label our coordinates. I'm going to call this one x1, and I'm going to call this one y1. I'm going to call this x2. I'm going to call this y2. I do recommend taking the extra second to label those. I just find it to be very, very valuable, and you won't make any mistakes. So m equals negative 6 minus, notice how my y1 is negative 8. So my formula has a minus sign in it. So I want to make sure that I represent the minus and then the negative 8. That's a common area where you can find errors with slope. And then, of course, we're going to say 7 minus 14. And as these numbers get a little bit bigger, you're more than welcome to use your calculator. But the numerator here will be negative 6 minus negative 8. That's really adding 8, right? So that's going to give us positive 2 in the numerator. 7 minus 14 is going to give us negative 7. And notice the 2 over negative 7 cannot be simplified. This is actually already simplified. So my slope will just end up being negative 2/7. And you're done. Now, I just wanted to kind of bring this to your attention here. So look at these two examples at the bottom. So you can ask yourself, well, what happens when your x values are the same? So if you had a situation where you had two coordinates that looks like this, where your x coordinates are the same, think about what that would look like if you set it up. Do you see how my denominators, right, my changes in my x's, it would end up being 0, giving you an undefined answer. So if you ever kind of recognize right off of the bat that the x's are the same, you know you have an undefined slope. And likewise, notice if your y values are the same. See this example where my y values are the same? That would mean that the numerators would end up being 0. And anytime you have a numerator of 0, that's going to simplify down to an answer of a 0 slope. So things to be aware of that might help you recognize things a little better. Okay, I've got two more things I want to take a look at, and these are more like applications of slope. So this first one is determining the slope from a table of values. So we've seen what a table of values is in our last unit of study, and we know what it means. We know that these are coordinates on the coordinate plane. But in this example, we're saying that these are coordinates that are on the coordinate plane and they're creating a line. They're creating a linear equation, we like to say. And we want to know what is the slope of that line. Well, there's a couple ways we can do this. We just learned that you can take two coordinates and use your slope formula to determine the slope of the line. So you can absolutely pick any of those two coordinates and do that. But here's another way to do it. Remember that the slope of the line is the change in the y's over the changes in the x. So let's just see what the change in the y over the changes in the x's are. Look at this first one. If I go from here to here, the change in my y is positive 2. And if I go from here to here, the changes in my x's is positive 1. So here it would be represented by 2 divided by 1, which would equal to 2. But let's just check all of the points just to make sure this is consistent. What if I go from this point here to here? So the change in my y here is positive 4. And the change in my x's is positive 2. So 4 divided by 2 would again give me 2. So it's pretty consistent. It's going to work the same way here. If I see my change here, my changes in my y is going to be positive 8. My changes in my x's is going to be positive 4, which would give me 8 divided by 4, which again gives me a slope of 2. So the slope of the line being represented by this table of values is 2. The last example I want to give you here is kind of a neat one. It says here, determine the value of y. So the line that passes through coordinate -2y and 6, 7 has a slope of 1/2. So you got to kind of picture what we're looking at here. They're giving us that the line has a slope of 1/2. They're telling us that, and we're kind of working backwards now. We want to figure out what are the coordinates that are going to be on that line that look like this. So we know that this is already one of the coordinates, but notice that the other coordinate is missing a y value. We want to determine what that y value is. So let's go ahead and use our slope formula to figure this out. Watch what we're going to do. I'm going to call this x1, y1, and x2, y2. And of course, this is my slope. So I'm going to set it up like this. 1 over 2, that's my slope. So my slope is equal to y2 minus y1 over x2 minus x1. See what I did there? Now, let's go ahead and simplify this down. 1 over 2 is equal to 7 minus y, and I'm just going to simplify this bottom thing. That's going to be 8 in the denominator. You see what we have here? Now we can use our understanding of proportions to solve for y. Remember this from Unit 2A? So I'm going to use my cross products here. and I'm going to multiply these. So I'm going to bring my work up here. 1 times 8 is equal to 2 times the quantity of 7 minus y. So 8 is equal to 14 minus 2y. You see what we did there? We did the distributive property. And then we just want to simplify this down. I'm going to subtract 14 from both sides. Negative 6 is equal to negative 2y. I'm going to divide both sides by negative 2. And y is equal to 3. Now, what does that actually mean? Remember, the y is what we were searching for. This is that piece of this coordinate that was missing. So now we know that the slope of a line that's 1/2 is going to pass through the coordinates negative 2, 3, and 6, 7. So we used our understanding of equations and proportions to solve this problem. All right, that brings us to the end of our lesson on slope.